Okay, good morning. Thank you everyone for coming and thanks for the opportunity to present my research here. Depression is one of the most common psychiatric disorders, and while with standard treatment options like pharmacotherapy, the prognosis is usually very good. Many patients are reliant on drug intake for their whole life, and some patients do not respond at all to standard pharmacotreatment. So our aim was to find out how to former MDD patients, so people with major depressive disorder, who are now in drug-free remission and are not reliant on intake of medication anymore, differ from the patients who are responding to pharmacotherapy but need to take in their medicine daily. For this, we set up a study that included 97 subjects. 35 of them were healthy, 32 remitted former MDD patients, so patients who experienced at least one episode of depression and are now drug-free and symptom-free for at least 6 months. And then major depressive disorder patients who were acutely depressed when we included them in the study. It were 30 patients, and we treated them with SSRIs. And then defined the ones who responded with at least 50% reduction in HAM-D score as responders. And we measured all of this group of all of our subjects in the study twice, so with 3 months in between, and the MDD patients did receive some pharmacotreatment, and the remitted patients were drug-free, as already mentioned, 6 months prior to inclusion and also did not receive any medication. The whole study was performed on 7 Tesla MRI, and we wanted to analyze our resting state data in a most unbiased fashion by taking into account changes in the whole connectome and not restricting our analysis just on some hand-picked ROIs or seed voxels. So therefore, we base all our analysis on this seminal paper by Biswal et al., who identified 20 very stable networks in a large data set of 1,000 resting state scans across the whole world from different centers. And he found out that these 20 networks are completely stable, consistently reproducible. So we thought this is a nice analysis data set as a seed. So we binarized these results and took them as a seed mask to reproduce the networks in our data for all our measurements and subjects, and subsequently looked at changes, at differences between remitted patients, so again, patients who are 6 months drug-free and symptom-free, compared to responders who already show a symptom relief due to pharmacotherapy but are still under drugs and still need these drugs to stay in a relieved state, so to say. So we looked at all these 20 networks for changes, and we found out that 19 of them stay completely stable, but there's one specific network that is showing differences between these patients' groups. And these differences are reflected in a higher connectivity of this frontoparietal network, which is also including striatal regions, with the ventromedial prefrontal cluster you see here. Now, the question is, and that this might be the final goal in depression treatment, how can we send more of our people who are now getting pharmacotherapy, how can we send more of them into full remission so that they are in a state where they are not reliant anymore on drugs? And maybe TMS, there is an option. So TMS is as already you might know, is a non-invasive way to manipulate brain activity by electromagnetic pulses. And it is nowadays an FDA-approved treatment, especially for treatment-resistant depression. But still, we don't really know how RTMS influences the brain in a way so that it alleviates the symptoms of patients. And to find more out about this, we set up a study with 60 healthy subjects that we stimulated on the left dorsolateral prefrontal cortex as the target for standard depression treatment. We stimulated them once on the DLBFC in a real session and once on over Vertex as a placebo control in the sham session. And we acquired resting state data, this time on 3 Tesla, once before the stimulation and then twice after stimulation to also get insights into the temporal evolution. We again took the same analysis approach, re-established those networks in the 6 resting state runs for each of our subjects, so in real session and in sham session, and then looked for changes across all possible runs, if there are any changes over time in any of the sessions. And again, 19 of the networks are completely stable, irrespective of run or stimulation condition. And then there's again one specific network, and it's the very same network, that is showing a specific alteration only after RTMS over left DLBFC. And this is reflected as changes again in the ventromedial prefrontal cortex. This finding is very nice in line with prior findings. For example, they have found more dopaminergic activity using PET and many other studies, which are nicely summed up by Mike Fox in this paper. And taken together our findings from both studies, we could show that when we apply RTMS over the left DLBFC, we find changes in a very specific network that are reflected in a higher connectivity with ventromedial prefrontal cortex here. And we find out that the very same network modulation is the one that is differing in people who fully remit from depression compared to the ones who are reliant on drug intake. And so we want to suggest that RTMS DLBFC may act by modulating the brain states in the way that is leading patients to full remission. Now, as a limitation, there are some subjects in our study. This is a large sample with 60 subjects, but there are some subjects here who don't show this modulation at all. And it's also well known in clinical trials that not all patients do respond to these RTMS procedures. And I think it's really important to stress out that we need to combine concurrently brain stimulation with imaging to find out in an individual subject if the stimulation works or not, because often we might not stimulate on the right position or just not with the right intensity. So I think this is really important, and we made some contributions here. We developed a dedicated TMS MR coil that is ultra thin and replaces the standard head coil. And since you can mount a TMS coil on top of it to stimulate through, you'd get rid of these artifacts you normally have from the TMS coil. And as you can see here, this results in a very high SNR and therefore a very robust bolt response we get here in this case on the motor cortex. And we found out that this response is dependent on stimulation intensity, so we are able to map here intensity-dependent effects. And if we move now on the DLBFC as the target that is most interesting in depression treatment, we again found that stimulating this node here, it's the same target again, not only evokes a local bolt response that we can detect at a single subject level, but that this effect also is shown in other nodes of the network, and it is also intensity dependent again. So left and right DLBFC here, for example, show nearly the same pattern when stimulated with different levels of intensities. And also the anterior cingulate is part of this network that you can see when you stimulate the subject and concurrently measure fMRI. And this again is comparable to what we observed in the larger sample. So you can see here with this online TMS fMRI setup that we can find out the mechanism that leads to these longer lasting changes than in connectivity. And with this I want to thank my supervisor Christian Windischberger and the rest of my team, and you for your attention.